Thanks for this opportunity to go through and discuss some of the, or one of the recent events that we encountered whilst flying our newly developed EM system. Now, this particular incident is both a little bit of a wake-up call or a surprise to us as much as it is a good news story. It's a surprise in so much as whilst we're aware of the potential for lightning strikes, we hadn't anticipated getting one on the second survey out. We didn't expect to experience the strike in conditions that were not conducive to what we would typically expect to experience this sort of activity. EM systems are traditionally not very resilient when it comes to any form of electrostatic discharge in the atmosphere, even many hundreds of kilometers away. None of the symptoms that we would typically see, first up, normally you would have an indication of your data has become poor or corrupt. And none of these had presented themselves prior to us experiencing the strike. Now, where we were positioned, we were flying southwest of Tennant Creek. Approximately 120 kilometers away from Tennant Creek was where we had the lightning strike. The time of the strike was that the guys had gone out, they'd completed the day's flying, everything was good. We were on way back to base and busy with the post-survey calibrations. The guys had climbed to an altitude of about 8,500 feet, and at that point they experienced a flash. The initial report was that it was at the front left section of the loop of the aircraft, and obviously at that point the system stopped functioning. We had two pilots on board, a total of experience of 22,000 hours between the two, roughly divided 50%, so it wasn't that you had one massively experienced guy and one not. So we had enormous experience. We had a formal review of the daily weather reports expected. There had been conditions anticipated approximately 3 o'clock that afternoon that it was going to get to the point where it would affect Tennant Creek. At the time of the strike, it was 9:50 in the morning. There was some high broken cloud present, and as mentioned before, there were none of the usual telltale signs of a charged environment. The initial failures was the EGT compensator circuit breaker tripped. Guys had a burning smell. Fortunately, no smoke in the cockpit, no visible smoke in the aircraft. They lost range on the VHF comms too, and the avionics went erratic for a short period of time. At the time, because they were busy with the post-survey calibrations, the bird was fully deployed, and fortunately the damage that was sustained was such that it didn't, and hopefully in the later slides we'll maybe put a bit of this in context, was such that the winch and the controlling electronics for the winch didn't suffer damage that would have resulted in either a manual retrieve of the bird using a mechanical system, or worst case that we would have had to eject the bird. On landing, the first explanation we got was the pilots, the engineers sat around, they presented or put their thoughts down. We submitted a formal report within an hour of what was around the incident and the fact that things were being investigated. Now, because the initial discharge or strike point had been noted as the top left side of the loop, that was the first place to go and look, which the engineer did and found absolutely nothing. We then requested that the engineer on site did a detailed inspection of the airframe as best to his ability and get the technician who was on site at the time to take a whole bunch of pictures and send them up to us back at Jandakot so we could also assist in the valuation of damage. Now, the first question that was asked related to these pitting marks on the front of the spinner. And once again, something that threw us a little bit off track at that point in time was that the prior engineer that was on site before the rotation occurred had reported that there were some stone marks on the spinner just through working in an environment where there's loose stones and gravels. They sent that picture through that we looked at in quite a lot more detail, and that little mark over there was essentially that point, and that discoloration there, and obviously the way that it's melted as well as just physically damaged, was for us a very big red flag saying, hold on, we've got a strike here that's not just limited to potentially the loop and the EM system, but possibly a whole lot worse. We then sent our head of aircraft airworthiness maintenance control to site to go and assist with the investigation, at the same time as gave him a couple more pieces of equipment that he could take with to review it. And as we had anticipated, the propeller showed signs of magnetism on various components, and as well as the engine mount as shown in the picture on the bottom left. At that point in time, obviously everything was grounded, and we made arrangements to swap out both the propeller and the engine such that the aircraft could then be flown back to Jandakot base for a very, very detailed inspection, which was then undertaken over a number of weeks. Rolling back a little bit, and this is where, for me, there's a little bit of a good news story in it, is through the design process, we went through a painstaking process of certifying or ensure that the aircraft would be as certifiable as possible, given that you've got this aircraft that's got all little bits hanging over it, for the purpose of lightning strike. And we developed a strategy to deal with it. It's aligned with FAR regulations and guidelines. And the particular strategy that we employed was presented to CASA in a report, which they were very acceptant of as part of the approval we had to operate the aircraft. And essentially it's really designing or dividing the aircraft into various zones where there's different risk levels, and then putting in strategies to deal with those specific risks. Now, from a time, engineering, financial perspective, it was quite a large investment. Some of the examples of the mechanisms we put in place were these huge bonding straps, conductive meshes within all the composite components. There's banks of gas arresters, which are for the purpose of lightning strike. Now, at this point, what's quite interesting is, although we believe the loop did certainly take a strike, the transmitter that was running at the time suffered no damage. The gas arresters, although they had done their job in terms of removing the discharge from the loop and getting it through the airframe, the gas arresters themselves didn't sustain any damage. This is a little bit of a pictorial representation of what actually happened. I've got a couple more pictures. I thought the presentation was going to be after lunch, so I figured putting in a whole bunch of pictures was a good idea. The initial strike was on the tip of the propeller. We noted after the final inspections that there were 2 exit points on the right-hand wing stinger. The UHF aerial underneath was pretty much broken in pieces. There was an exit point that we identified at the top end of the rudder, and at this point where the tow rope for the towed array connects with the pulley mechanism, there's a pulley. The pulley had sustained some pretty severe damage, and we could trace the discharge path all the way back out and through the bird. The images there, that's the tip of the propeller where it got hit. That's probably about 2.5 millimeters across. It's a tiny little spot that was initially just not identified even in the initial investigations. The exit points on the right wing stinger are shown by those little marks there, and one of them, just for the purpose of this exercise, I've zoomed in, and essentially it went to a depth of about 1.5 millimeters and stopped dead where the mesh was that we have that runs through the components. So for us, that was a fantastic indication of the fact that that mesh within the composite had done its job. The alternative in sort of a situation like this is that obviously carbon fiber, being a conductive material, can sustain some pretty catastrophic damage when exposed to high voltages and currents. This is the antenna with what appears to be a pencil shoved in it, just to try and display the problem a little better. In the tail and midsection of the aircraft, I've mentioned the pulley. It had a burn mark approximately 5 millimeters across, 4 millimeters deep in the final exit pulley, which was the entry point to the cable. There is where the strike blew out through the cable, and this is the tail section of the bird where the electronics had obviously sustained significant damage. The data system in the aircraft was pretty much written off. A number of cards had sustained damage that was irreparable. The last image shows the exit point at the top edge of the rudder. We sent obviously the propeller and the engine off to go and get the necessary reports done and evaluation on the damage. The propeller was damaged, that one of the blades, the one that had been hit, had suffered softening of the alloy, and as such needed replacement. At that point, just due to operational reasons, we just elected to get a new propeller in whilst we were dealing with the repair, which we did. A couple of the images here is just from the engine report, showing the typical damages that were evident after the strip down of the engine. Nothing massively catastrophic that would have resulted in an immediate failure of the engine without any kind of warning, but certainly within a few hundred hours we would probably have noted some bits of metal in the oil and that sort of symptom. So the engine was sent for overhaul, which we received about 6 weeks later, and in the interim we flew, test and commissioned the system using a loaner engine or rental engine. Some lessons learned. I think the biggest lesson that we can take from this is that it was an environment where we, although had employed certain design strategies to deal with it, we never really believed it was actually going to become a problem. I think the likelihood of the event, a repeated event, probably still remains reasonably low, but it's certainly a stark reminder to all of us that it's expecting that unexpected that is really what's important, what we do in our daily business. The real plus side is that all this time and effort was rewarded with an aircraft that landed safely. Nobody was injured. The system sustained damage, yes, but no damage that affected the immediate airworthiness of the platform. And also, for us, it was quite valuable was that the conservative approach taken once we had the initial reports that it was just the loop that got hit, which was replaced in any event. But the initial reports being the loop, initial damages indicated nothing too serious. It would have been pretty easy to carry on at that point, whereas obviously from our perspective, we stopped and paid attention, and I think that's probably something that we should be taking away from this.